everyone, and welcome to Into the Terminal. I'm joined by Nate, my co-host, and today we're going to be talking about Systemd. So, Nate, why don't we jump into your terminal and you can do the critical path on controlling services with Systemd.
I just realized I missed a perfect opportunity to wear my Everybody Loves Systemd shirt. Dang. All right.
Everybody loves kittens, or everybody
Yeah.
chocolate.
Right. So we're going to start off with some basics, right? We're going to start and stop services. We're going to do some status and, maybe some things that you don't already know, right? If you're working with RHEL in the past, 3 releases now, you're probably familiar with some of what we're doing here. But anyway, so first of all, I've got Apache's HTTPD installed on my machine. What if we just want to start the service up, right? So simple, Systemctl start, and then the name of the service. The other cool thing is, if you want to start more than one service at a time, you could do like HTTPD and I don't know, MariaDB and 3 other things, right? And it'll start all of them, right? Obviously, if you want to stop it, simple as stop, right? And then this will stop HTTPD. But right, this is like table stakes, right? Starting, stopping services, whatever. What if I just install a thing and I want to start it at boot, or maybe I can't start it yet because it isn't enabled, because Systemd makes you enable services before you can actually make them start at boot and whatnot. So I also have MariaDB installed, which, coincidentally, my other example. So I installed it, but I've done nothing else with MariaDB. So we're going to just say, look at the status, right? And you can see right here, it says that it's loaded, but here it says it's disabled, right? So let's enable it. And once we enable it, then we can start it up. And enabling it also makes it start at boot time, right? So if we do a systemctl enable MariaDB, this will basically set up a bunch of symbolic links within etc systemd that adds it to the various different targets, right, that your system would then end at while booting, right? And targets is a whole other topic that we're not going to cover today, but Systemd has a bunch of targets that it knows about. Like there's a networking target and there's a like multi-user target and whatever.
We'll
Go
cover
ahead,
those
Scott.
next week when we
Yeah,
talk
there we
about
go.
different types of unit files.
Right. All right, so now if we do status again, we should see that it's enabled, right? But it says it's inactive or dead, period, right? Poor MariaDB has died, although it's not dead, it's just not started yet. But before I did that, I wanted to show you one more thing. If we enable the service that we now do not want enabled anymore, of course, we can then disable it, right? And then if we do a status on it again, ta-da, surprise, it says now that it's disabled, right? But I did that. You might say, well, why did I disable it if I wanted to run it anyway? Because I want to show you another really cool command. Normally, what you would have had to have done is enable it and then start it. But there's a cool trick or a cool flag you can pass to systemctl. When you enable it, I go back up to the enable command here, do -- now. Just like you're talking to a child. Do it now. If you do now, -- now, it will not only enable it, but start it. If we check the status now, assuming that the service that you just installed didn't need any other configuration to make it work properly, it'll start it back up, or it'll start it along with enabling it. And you can see right here, MariaDB is one of those services that even if I didn't configure it, it's probably not in the state I want to use in production right now, but at least it'll start. And here it is, started up and running. So there's my crash course.
Yeah, and just to reiterate, enabling and disabling controls whether it starts when the machine boots automatically or stays turned off. It doesn't control things like installation, software, any of that kind of stuff.
Right.
And then with -- now, you're actually doing 2 things. You're enabling it so it will start at boot time the next time you boot this machine, and also starting it up right now. Hence
right.
the -- now.
Right. And again, like I said, you can do this on multiple services at the same time if you wanted to, right? So just something to keep in mind if you're trying to, like, if you're just setting up a new machine and you have like 3 different services that you all want to start, or you're trying to automate it, you can do that all in one line, which is really nice.
Right. So stay with us after the transition as we move into talking about some other things with Systemd. Specifically, we're going to be talking about using the journal log, and Nate's going to show us some stuff on that. I'm
Yep.
going to talk about Systemd Analyze, which is a cool tool to help you identify where your system is spending time at boot or when starting a service. Then we'll throw it back to Nate, who's going to talk to us about Systemd Timers, which is a way that we can schedule things to happen on the machine. It's a lot different than cron. And then I'll round us out with restarting services at the end so that when a service fails, we can automatically start it and some options around how we might want to do that. So stay with us after the transition. Oh, I forgot to say, don't forget to mash that like button. And if you know someone who is interested, share it with them. And if you want to be notified that we're doing stuff like this, don't forget to subscribe.
Yeah.
Wow, that was
We're professionals. Can you tell?
Manager Scott's the worst. All
Manager
right,
Scott's the worst.
Nate, let's talk about Journal.
Yeah. So obviously, like when you're troubleshooting services and whatnot, you have to be able to see logs. And Systemd has this concept called the journal, which is very similar to what you might call or what varlog messages used to be. And sorry, Eric, you didn't have to turn off the terminal. Switch us back, and I'm gonna get started. So it's the system journal. There's, as you might expect, given the sort of commands that you see when you're working with Systemd, there's a command called journalctl. And if you just run it with no other commands, it'll just show you what it has in the system journal inside of a pager, right? So I think it's very similar, or maybe it actually is less that it puts it into. And in here, you can see like this is from the point where the system booted. You can see right there at the top, it's giving me the kernel information that you would have expected as the first log entry that it logged as it was booting. And then you can just, sort of go around. You can do searches and whatever. Like, I don't know if I want to search for, I don't know, for September, because we're in September and that's the start of all my logs, right? Which is great if you're trying to find a thing, right? If you're trying to look for a specific thing. But obviously, there's some issues with this, right? Because it's in a pager, you can't pass it into another tool like grep or sed or awk, which you might be used to for parsing logs. And it's also, if you notice, some of these lines have this little arrow at the side. That means they're wider than the screen. So you have to use the left and right keys to get over to them, which isn't the end of the world, but it's different than what you might be used to if you're used to dealing with just flat text files. So I'm going to quit that with the letter Q, just like you would leaving or exiting less. And there's a couple other things I wanted to show you. One is you can use journalctl to show you logs within like a time frame. There's a since flag and an until flag, which I believe you can use in combination to get a window, but I'm going to show you just the since flag. So we're going to do journalctl -S for since. And then let's make a date that's like 2023, 09. What's today? The 8th? The 9th? Today's the 8th. 08. It's right there in front of me, right? And then we need a time as well. Now, these systems are running like UTC. You can see that the log that I have here started at around 3:54:07 UTC. So we're going to go like 3:55. What this should do is it should give me basically the same output, except it's going to start at the time that I gave it here, right? So the beginning should be right there at 15:55:02, right? So obviously, like if you have an idea when an event happened, this is really helpful because you can then just plug in, like, I want you to start at this time instead of me having to page through all that stuff. There's lots of other filtering commands. I don't want to go too deep because we only have so much time in an episode, but just know that if you look at the man page for journalctl, there's a whole bunch of options you can get to. Another common one is, what if you just want to jump right to the end? Instead of opening up the pager and then hitting end, you can do journal-E, takes you right to the end instead, right? You can see right there, it says at the bottom, end, I'm at the end of the file. If I scroll down, there's nothing. If I scroll up, there's things, right? Let's see. There's the end. You can look at a specific unit. So if you want to look at the log file that's specific to like HTTPD that we started earlier, journalctl-u for unit HTTPD, and it'll show me just the logs that are related, or the system logs anyway, the journal logs that are related to Apache's HTTPD. And that's basically when I started it up earlier in the demo. There's also an extended output. If we go back to the -e output and add an x, -xe, it gives me actual data that goes along with where I might find more information about these different log files, right? You see there's links to Red Hat support docs in here. There's like things like what service called it, stuff like that. So these are useful if you're trying to troubleshoot a problem. You get some context right there within journalctl. And you can also do that for the unit file. U for unit file, like we did before. I do that for HTTPD, and there you go. It says, look, we stopped Apache, and here's some information about, stopping Apache, right? So these are all really helpful things if you're trying to troubleshoot an issue with a service. Obviously, if there's an actual problem in the logs, this will be a lot more useful than just all this nice, happy green text. So just keep that in mind. And yeah, I think that's. Oh, there was another one I want to mention. I talked about the pager. If you don't want the pager, let's go back to -e, I guess. If you do --no -pager, just like that, it'll give you the output just like you'd expect if you had catted a log file. So, all right, there's my crash course on journalctl. Any questions pop up while I was in there?
There were a couple. Shantanu asked, I'm sorry, Vincent asked, are these
Let's
are these
confuse the producer.
yeah, when I say the wrong things. So are these logs compatible with syslog?
So RHEL still runs syslog in the background. I believe you can still, if you're asking like, can you collect these and send them off to a third, like to Splunk or to some other log storage system? I think the answer is yes.
So I was thinking with the question that it was the format. And so we could see that it uses a similar format to syslog of date,
Right.
time, system, service, and then message. But the default configuration will also take this data and send it to our syslog.
Right.
So it goes both places. Long, long ago, when systemd was a mere glimmer in Leonard's eyes, there was a thinking that journal log or journald would kind of take the place of system.
Of our syslog.
Yeah, but that's never really happened, and so we just kind of kept with the status quo. The big difference for most systems out of the box is that journal D is not persistent, and we talked last week when we were talking about system roles on how you could make it persistent,
Right.
um, but it's not persistent and exists in memory only
That is true.
by on RHEL systems, unless you make it persistent as a post-installation activity. And that's the big difference between them, I think. All right, there was also a question from Shantanu about, there we go. Thank you, producer Eric. I cued you correctly this time. Does RHEL have the systemd docs specific to the version shipped with the OS? The free desktop page is off of the latest version, right?
Yeah, so the docs for anything included with RHEL should be relevant to the version that was installed, right? If you're talking about like if I'm looking at man for journalctl or man for systemctl or whatever, yes, that should be relevant to the version that's installed. Of course, if you go to the upstream project and look at their docs, then yeah, that's probably going to be the latest and greatest, not the one that comes with RHEL.
Yeah, and the RHEL docs
Yeah,
that are on the Red Hat documentation page are version specific. So there's like a Red Hat Enterprise Linux 9 version of the system administration guide as an example, or the system security guide. And that is version specific for 9 and gets maintained, updated, and curated for 9. There's also one for 8 and also one for 7.
right.
So yeah, we keep that version specificity in the Red Hat branded provided product documentation.
And I see a comment here from Shantanu about Amazon Linux, which is a Fedora derivative, ships without rsyslog by default. It's so one, Amazon Linux is not just a derivative of Fedora. There's a whole lot more that went into that than just like a snapshot of Fedora. So there's that to think about. And then on the other side, Fedora does not always dictate what becomes RHEL, right? So it's hard to say yes or no, right? That rsyslog will go away in RHEL. I Who knows, right? But just to say that Fedora or Amazon Linux that was based on Fedora no longer has our syslog is it's not safe to assume that it won't that it's also going away in RHEL. Just wanted to cover that. And yes, systemd stuff is in the admin guide.
All right, so shall we change gears to talk about systemd analyze?
Sure thing.
All right, so systemd analyze is a tool that we use for getting data from systemd activities. So I'm just going to show you a couple ones that I found really useful. Systemd analyze blame. So systemd analyze blame is going to go through all of the unit files, all the tasks that systemd performed, and tell you how long each one of them took. And it's going to organize it by the longest to shortest. So to start up the kdump service took 5.617 seconds. To start up the tuned service took 2.853 seconds, and so on and so forth down the line. We can go to the very end, and we can see that the mob probe fuse service took 7 milliseconds. All right, so where this is interesting, if you are trying to troubleshoot why something is taking long to boot up, this is all the stuff that systemd has done. So you can very quickly see what's taking the longest as part of your systemd activities. In this system's case, it's kdump and tuned. And then we get into some Google stuff, which is my cloud provider jobs. So these aren't even ones that I picked. These are part of the image that is required by the extra Google Cloud software. And so you can start to find hotspots in your booting to figure out which services are having problems or may need to be tuned, or maybe even ones that can be eliminated entirely and you can save a little bit of time on your boot process. So I
Or
found
to be honest, a service that takes a long time to start may be normal, right? Depends on the service. Some services just have a ton of things to do when they start up, but it's good to know. This is a great way to say, oh, well, the OS itself is booting really quickly, but service X, which is integral to our workload, that's what takes a while, right? And then so why does my system boot slow? Oh, well, because it's running this thing, and that's normal.
good point. And a lot of the times I hear people say the system is slow. And a lot of times they're talking about something like booting. Well, if you're starting up things like a huge database and web services and some supporting things like a message queue and flushing queued stuff, like that stuff can take a while, which would explain why your boot is slow. In reality, your boot is normally timed. You're just doing a lot of stuff, so it takes a while. But that might be if that's really a complaint and it's something you have to address, it'll give you an idea of where you need to start looking to try and cut time out of that situation. All right, another one that I find really handy, systemd analyze, critical chain. So this shows you a tree view of the things systemd did to get you to a specific point. And the specific point for this one is my SSH session. So the machine booted to multi-user target, which took 13.015 seconds. And then systemd service started, which was an additional 53 milliseconds. And that's how long it took, about 13 and a half seconds. 13,
So
13.1
did it take the context of the process that it's running within, and that's how it got this tree? You could specify a different process if you wanted to, right? Like, why did it take so long for service X to start?
Well, so that 13 seconds is like a whole bunch of stuff.
Right.
So, yeah, if you have a specific service, like in a bit, my second situation deals with Apache. And so if we wanted to see how long it took for HTTPD to be started in the critical chain, right? This is the series of events that had to happen for this service to be started. And it shows me like how much time was spent at each thing as it built up the chain of events to get me to the ultimate process that I wanted to start up. Um, so that's the other way. You can give it a unit file or a specific service name, and it will figure out all the things that were required to have happened in order to get you there. One of the big benefits of systemd that was better than its predecessor, init files, is that it can do things in parallel.
Right.
And so oftentimes, like what we're doing at boot time, maybe several things at the same time. So
Right.
even though some take a long time, other things could be operating as well, and that's cool because we're just using that multiprocessor and um, or multiple processors and starting things up in parallel. So this will give you a readout of specifically what things had to happen first before your thing could get started, independent of all that stuff that could be done in parallel.
Right. And the parallelism, of course, means that there's dependencies and whatnot. And we may get a little more into that as we get a little deeper into systemd in future episodes. Um, so yeah.
All right, so that's a little bit on systemd analyze to like figure out where it's spending its time. Nate, you're going to talk to us about timers.
Yeah. As soon as Eric switches us back. There we go. All right. So you're all familiar with cron, probably, or crony, which is the cron replacement. Just does effectively the same thing on newer versions of RHEL. Did you know systemd also has sort of a cron replacement? Or I guess you could say it is a cron replacement. You can manage timers, which are basically the same concept as a cron job. You specify a task, and you can add that into systemd, and systemd will run it for you on a given cadence, right? So we're going to start out by just listing the timers we currently have. So list timers will tell us what timers. Oh, wait, what did I do wrong here? Unknown command verb list timers. There's a plural. You can see here we've got timers already defined. Now these are things that either came from RHEL or came from the cloud provider. See, there's like a log rotate in here. There's some Google stuff because these are Google Compute clients or images, and it's in that same pager that the journalctl was using, right? So I had to hit Q to get back out of that. But what we can do is we can define a new timer, which is what I wanted to show you. Now, there's a number of ways you can get this done. I'm going to show you a very basic example, but there are other mechanisms for how these timers are defined and even how you want them to run or how you want them triggered. You can have timers that are triggered off of other events and things like that. We're just going to do a time-based timer because that's kind of the most common use case that you'd think about if you're replacing cron. So we're going to define a new unit. So give me a second here. This I definitely want to copy and paste, so I make sure I don't get it in here wrong. So we're going to paste in. We're going to edit a file in etc systemd system. We're going to call it mytimedjob.timer. And let me get the contents here, and then we'll walk through the contents after I get them pasted in here. Go to insert, and then actually, let's just make sure it doesn't try to do any formatting for me. Paste this in here. All right, so we have to define it as a unit, give it a name, and we tell it what it requires. Now, there's another service called my job that I've already defined, and I can show you that in a second. But basically, that job just runs a shell script. I didn't want to go too deeply into defining a service because that may be a future thing we talk about. But I'll show it to you in a minute. So job that runs frequently, simple as that. You'd probably want to give it a better name than that. It depends on, or it requires my job service. That's those dependencies I was talking about. This is the actual definition for the timer. what's it going to call? It's going to call this unit called myjob.service, and on calendar, which is basically run this at a given date and or time, right? Or get date and time, I should say. You can see this format has a whole bunch of asterisks in it. That means any day, any month, any year. So basically run this every day. That's what the star dash star dash star means. Any hour, any minute, every 15 seconds. Now this comma separated list is on the minute, so 00, 15 seconds after the minute, 30 seconds after the minute, and then 45 seconds after the minute. And then it should loop because I told it to run it every minute. So at the next minute, it should start again at 0. And the install just says that this is the target. Remember, we talked about targets before, that this should be installed during. So we're going to save this. And then just like any other service, we have to enable this, right? So we're going to just paste in the command that will enable it. You should recognize this from the critical path. And now it's enabled. So if I do a systemctl list timers again, boom, we should now have a new timer in here called my timed job right there. And the cool thing about this is if you've ever had to troubleshoot, when will a cron job run? When did it run last? Right? There's a bunch of parsing through log files to try to figure that out, and then like date math in your head. This just tells you. It tells you when it ran last. It tells you when it's going to run again. That's what this left column is all about. So in 1 more second from the time that I ran this, it's going to run my time job. If I run systemctl timers again, now it's going to tell me, here's my time job again. Here it is. 1 more second, it'll run it again, and it ran it last at 14:27:58, right? Now, I said that there's a job that it's running, but I'm not showing you anything about the job that's actually being executed. So remember journalctl? What I did is this job, all it does is it echoes the date and time, or I think just the time. And that'll show, because it just echoes it to standard out, it'll show up in the journal. So if I do a journal control -E, it'll show us the end of the logs. And you should see here that it's running my job successfully. My job service deactivated successfully. It activates it, it starts it, and then it runs it. You can see here the time is, that's my job running. Here's job.sh, right? Job.sh. So there we go. The timer is working. Now, I think if I do, I should show you the content of my job that I told you about, right? This is a very, very simple one shot, they call this, right? Type equals one shot. That's the type of service that this is. It's just a service definition like anything else. And what this tells it is call this thing and then exit, right? So it's running job.sh, which is literally just a shell script that runs date and puts it to standard out. And there you go. That's timers. Do you have any questions on timers? Looks like there's a bunch of chat going on.
Yeah, it's just chat. Nothing on timers.
Okay. So yeah, if you're using cron jobs, you might want to look at timers because they are more flexible. And, you know, I don't want to force you into change, but.
Well, and the place where timers are really handy is when I have something that I would normally do with a cron, or I historically have done with a cron, but it's tied to something specific. So like in the last couple episodes, we've talked about building containers and starting them as services with systemd. Well, what if there's something like your container needs to check in to see if there's an update available? That would be really easy to automate with a timer. And then as you're like packaging up stuff to go with your container, it's a file that gets added to whatever you're sending with your container stuff. Same thing with your unit files. Whereas a cron job like goes in a completely different directory. People have to like put it or add it to the cron tab on their own or through their own user account. Like the mechanism is much less smooth because you're like bolting all these random Linux things. Whereas timers, it's with that service, it's with that unit. You can just drag it along with you by just grabbing the file.
And I did notice that there's also, you can define timers right at the command line. You don't have to go through all that effort of making a service and a timer. But I think that the functionality is a little more limited that way. I didn't want to have two examples for the sake of time, right? But just know that there is a way that you can give systemctl a timer job right at the command line. So for automation and whatnot, that might be quicker and easier.
All right, so we have one last thing to wrap us up, and that is restarting jobs. So let me jump into my terminal here. So earlier, we were running Apache, and I'm going to, instead of using systemctl, I'm going to use ps. All right, so there's my Apache jobs running. But maybe something happens and the service gets killed off. So some random thing happens, like, I don't know, that. So service is killed off, and it was killed off in a not very convenient way. So it's not like I sent the terminate signal, which systemd would figure out how to gracefully terminate all these jobs. Instead, like something drastic, right? Core dump, you know, seg fault, something weird happened to the service and killed it off randomly.
Ended abnormally. Yes. That never
Or
happens though.
never happens. Or killer started up and smacked it. Oof.
That never happens either.
Right. So one of the other really nice features of systemd is that you can protect the service by having it automatically restart it. So I'm going to do a couple of things. One is I'm going to copy the systemd unit file from the user directory into etc. All right. So I'm going to grab the userlib systemd system httpd.service unit file. I'm going to put it in etc systemd system. And here's why I'm doing that. If I'm going to make changes to vendor provided things, I should make those changes in etc. If there exists a file with both the same name in etc and in user, the one in etc is preferred because we assume that you created that file with the same name to supersede, right, to be more important than the one that lives down in user. The other reason we're doing this, if I were to upgrade Apache, one of the files provided by the Apache RPM was the systemd unit. So it could potentially replace it with a new one, wiping out any changes I would have made in the past. But if I copy to etc, now it's my file that I manage. And if the Apache RPM replaces it, my file that I manage is still in place and still supersedes or is more important than the one that Apache natively provided. So as I'm adding
There
these additional options, my things stick around. Nate?
there is, I believe, also a way that you can tell systemd these options that I have defined replace these options from the core unit file, right? But I don't have the syntax in front of me. I think it's systemctl edit lets you do that.
Yeah, and you can do like basically it'll only do the differences, or you can actually define the unit and add in the parameters you want, and it will
Right.
supplement what's down there in um, the user version. But
Right. Not trying to derail. I think there was a way to do that, which could be cleaner in some circumstances, or could lead to more headaches later, depending on how you look at it.
I just wanted to make it quick and easy, so I just
Yeah,
pulled a whole.
yeah. No, that's fine.
All right, so the first thing we're going to do is we're going to go down the service section, and I'm just going to add. Where is it? Looking at my notes. Restart. Run failure. So what that says is if we notice that the service is no longer running, we should start it up again. And the other stuff here in the service section tells me what that means. Like I should execute the user sbin Apache or HTTPD program
Right.
and these options and other stuff. So a restart of failure says do this service section again when I start it, but do it again if it fails. All right, so let me write and quit. And I've added a new file to the systemd architecture. So I'm going to do a systemctl daemon reload, and that will cache any new files or any changes to files that I've made.
Yep.
So systemctl restart httpd. So now we should be running. I can just double check that by looking at my PS. There we go. And so if we just to prove that it's working, the process ID of Apache is 2056 with a bunch of worker nodes. So if I do same killall, which we saw was effective last time, and then we PS it again, right? We got a new process ID because it was respawned.
And I bet journalctl would tell you that it died and was restarted.
Probably. So that's pretty good, but we can do better. Because the other thing that we're going to do, or what could happen, is this process actually has like a legitimate problem, and now it like fails, starts, fails, starts, fails, starts, fails, starts, and just like is in this horrible loop of terribleness.
Which not only makes it hard to troubleshoot, but could theoretically maybe even cause data corruption if you're dealing with like a database or something, right?
Yeah, it depends on what the service is. But
Yeah.
even so, like there's CPU implications
Yeah.
for starting services. Like there's a whole bunch of stuff that happens. And so what
Or,
we
you
can
know,
then
your admin logs in to troubleshoot why the website is down and the website is up because he logged in at the right exact moment.
or he logs in and it's like super slow because he's not able to get enough CPU power to his shell.
Right.
So we're going to add in a little bit of more protection to our restart. So what we're going to do is go back into that file. And before we added the restart on failure in the service section, we're also going to add a couple of options to the unit section. Specifically, we're going to add in start limit interval sec. So this says if I notice that it's dead, I should wait 10 seconds and then start it. And then if it still dies, or I notice it's dead again, I should wait 10 seconds and then start it. Actually, I take that back. If I notice it dies, I should start it. And if that dies, I should wait for 10 seconds before trying again. Let's put it that way.
Right.
And then the other thing we're going to do is we're going to add in a start limit burst. So I will try to restart the service a maximum of 2 times before I just figure out that it's
Which is
busted.
reasonable.
I should
Yeah.
give up.
If it doesn't come back up after 2 attempts, then obviously there's some larger problem.
All right. So I changed my unit file. So I'm going to go ahead and reload the unit file so it'll pick up that change. And then I'm going to restart Apache. And then I'm going to show you that it's there. And then I'm going to kill it off. But it successfully started back up. So I'm going to kill it off. And it successfully started back up. And then I'm going to kill it off. Maybe. There we go.
There we go.
So
now should it be waiting the 10 seconds now, or should it not try to start again?
I think it should not try to start again.
Okay.
So, but that's that may also be dependent on how fast I was killing it off.
Yeah.
But that's the point, is that like we'll retry a little bit, but if we're not able to successfully start it up after the retries, we should just hang out. Someone will
just
come
leave it down. Let the admin come help. Yeah.
Exactly.
This is when your alerting system starts to go crazy at 2 a.m.
Yeah, but if
it happens to hop in the car,
like a core dump, or not core dump, but a seg fault, and you start the thing back up.
Yeah.
And for whatever reason, that data wasn't in there, or it got a fresh memory footprint, so it didn't have the same seg fault problem. This would keep you from having to be woken up at 4 a.m.
Yeah, right. If it was just a temporary issue that made it die, yeah, which does happen, right? How many times have you just restarted a service and all of a sudden things seem fine again? Normally, it's indicative of a larger problem. So you probably want to, if your systems are automatically restarting services, you're probably going to want to set up some sort of log monitoring that tells you when it happens. Because if nothing's telling you, you may think everything's fine when it's not, right? And realistically, 28 times a day, HTTPD is restarting. That's probably bad.
All right, and I see that Shantanu asked a question. Where in the man pages is the long explanation help of start limit interval sec? I don't know. I actually found it from a really great enable sysadmin post on systemd. So I did not find it out of the man pages. I pulled it out of a blog from one of Red Hat's blogs. So it may not be documented in a man page.
It's probably documented somewhere, maybe in the upstream docs or even in the RHEL docs, but I'm speculating. It's got to be documented somewhere.
It's documented in systemd.unit.
Oh, there you go.
So that's what we're covering today for systemd. However, this is the first of 3 planned episodes on systemd. So Nate, what's our episode on systemd next week?
Let me find it in the notes. I think we're doing some more advanced things, right? Next, building a systemd file. We're going to build unit files.
And not just that, we're going to talk about the different types of unit files.
Right, right. So we covered a service and we covered a timer today, but there's lots of other items that you can define within systemd.
And I wouldn't say, Nate, that we covered a service.
We talked about them. You're right.
We used one. So we'll talk a little more detail about what that means. But Nate did a great job on timers and went into a lot of depth on that one. So that one will probably move pretty quickly through next week.
Right.
But we'll also talk about things like socket files or slice files or targets. That's something that Nate mentioned in the critical path that we didn't talk about yet. So
Yep.
we'll talk about that.
I lost track of what I was going to say.
It wasn't important.
The sockets is really neat technology. That's what I wanted to say.
And then in a couple weeks, we'll talk some more systemd. So that's what we have on tap for Into the Terminal for the next couple episodes, and then we'll see after that. So Nate, any parting words of wisdom?
Everybody loves systemd.
Happy Into the Terminaling, everyone. We'll see you next week.
Yep. Have a good one.